Scientific notation is used to be able to take either a very large number or a very small number and condense it into something that's more manageable by using exponents of 10, powers of 10. So now what we're going to look at first is going to be looking at how do we take a standard number and turn it into scientific notation using an exponential. So we have two different values here. This number here is 19,300. Okay, so looking at this number, the first thing you say to yourself is that this is a number that's greater than 1. Okay, so when it's greater than 1, then you already need to recognize to yourself that your exponent is going to be a positive number. Okay, but now how do we determine that exponent, that power of 10? What you need to do is recognize where is the end of the number where the decimal place would be represented. At the end of the number here, we would have a decimal place here to end the number. So it's not written here because those zeros are not considered significant in this example. But you would recognize that the decimal is always at the end of a number, and you're going to move the decimal place to the left. 1, 2, 3, 4. 4 places. How do you know when to stop moving to the left? You want to move the decimal until you reach a value that's between 1 and 10, because everything is in powers of 10. So the way that I move this 1, 2, 3, 4 positions to the left will give us then 1.93. And I'm not going to include these zeros because those zeros are not significant. So the significant numbers are 1, 9, and 3. 3 significant numbers. And then this is going to be times 10 to the power of 4. So now this allows you to represent your final answer as an exponential using scientific notation, and it still represents the correct number of significant figures. Okay, so of course, this is also much more helpful when you have a very, very large number. So we'll be looking at some more examples to look at very large numbers and how we can condense them. Okay, so for right now, this is just introducing you to the concept of what you need to do to convert the standard number into the exponential, and then we'll do vice versa, exponential into standard. Okay, so this is for when the number is greater than 1, you move the decimal place to the left. Now, when the number is less than 1, so it's a decimal value like this here. So what we have is 0.000000256. Okay, so writing out all those zeros, you could potentially make an error in writing out all those zeros. So that's when scientific notation becomes helpful. Okay, so now to write this value in scientific notation, what we're going to do is recognize where the decimal place is, and we're going to move that decimal place to the right this time until we reach a number between 1 and 10. So moving 1, 2, 3, 4, 5, 6 places takes us to a value 2.56. 2.56. Okay, so now we don't need all those zeros because they're not significant. So this is our way of condensing it. And then now when we have a number less than 1, the exponential power, the power of 10, is going to be a negative value. Okay, so how many places did we move? 1, 2, 3, 4, 5, 6 places, and it's going to be negative, -6. Okay, so when it's less than 1, the exponent is negative. When it's greater than 1, the exponent is a positive value. Okay, so that's an example there of standard to exponential. So before I move on to the next part here, I want to show you what if I had a 0 at the end of this number, or multiple zeros at the end of that number. If we put a 0 at the end of this number, this 0 is significant to your answer. So this 0 is going to be kept in the scientific notation. You would write this as 2.560 times 10 to the negative 6. Okay, because there's a reason why that 0 is there. The measurement was accurate enough to be able to include that digit. So it must be included in your scientific notation. Okay, so that is another way to make sure you are using the correct number of significant figures. Okay. So that was standard to exponential. So I'm going to go the opposite, and we're going to next go exponential to standard. Okay. Now in this example, what we're going to look at here is 5.88 times 10 to the 5th. That's going to be our first example. And then our second example is going to be 6.29 times 10 to the negative 3rd. Okay. So when you're going from exponential to standard, the first thing you need to recognize is my exponent positive or negative? When you see that the exponent is positive, then you know that your number is going to be greater than 1, so it's a large number, and you're going to move the decimal place, that number of places, to the right, okay? So to make the number large, we move the decimal to the right. So let's say we have this 5.88, and we want to move the decimal place over 1, 2, 3, 4, 5. Okay, so these spaces here are going to be filled in with zeros. So this is going to be your answer here to change this exponential value into a standard value would then be 588,000. Okay. Now the next example here is 6.29 times 10 to the negative 3. Now this value, what we need to do is recognize that we have a negative 3 exponent. When we have a negative exponent, it's a small number, less than 1. So if it's less than 1, then the decimal place needs to move to the left. Okay, so we start here at this decimal place, and we're going to move it to the left 3 places. 1, 2, 3. Then we put a decimal place there and fill in these spots with zeros. So then now this answer is going to be 0.00. So this 0 is just a placeholder. This is a habit that I have. I always have a 0 before the decimal, just as a placeholder for the ones place. So 0.00629. Or it can be just written as 0.00629, okay? I would accept either or. I'm just in a habit of writing a 0 before the decimal, okay? But both of these numbers mean the same, okay? So that completes our review of scientific notation.